Here we have an example of a solid state battery that charges extremely fast and discharges as a normal battery would. Here is the material that it's made of. It's very light. If I compare it to a normal battery, it only weighs a few grams. I'm going to give you an example. Here's a cell that I made. It's the same size as a cell phone battery. It weighs 33 grams, and 1 centimeter cube of that same material, which is actually the solid state electrolyte, is only about 2 grams, 2 to 3 grams. Let's have a look there. Take this off again. That's 34 grams, and if I add that 1 cube, that's 2 grams. So it's extremely light material. It's very strong. It can be used, as in this form where I made a mold. It can be used for building. So one of the ideas that we have for this application of this type of cell is to build blocks. This is a slightly modified version of the electrolyte, solid state electrolyte. It's stronger than cement, was as strong as building concrete and cement, and one can build a home or a house out of it and store your energy in the walls. It can be cycled many times. I've already cycled this cell over 300 times without any problems. In fact, the performance is improving over time. And I'm going to give you a demonstration now. It's completely discharged. I'm going to demonstrate its charging ability, how fast it charges. I have a 12-volt car battery here. The reason being is I'm looking for quite a few amps so that I can charge it up quickly, because we need amps. And this cell can take any voltage up to about 20 volts without getting hot or exploding or getting damaged. It also it charges extremely fast when you have a high amperage, so we're going to give a demonstration of that now. I'm going to connect up the negative side first. And here's a positive. I'm going to leave it for a minute or so, just so that I can show you how quickly it charges up. Here we have another cell that is completely discharged. You can see the LED is very dim. It's been on here for about 4 days. I'm going to disconnect that. It's a cell that's identical to that one, except it's got slightly less electrolyte in it, but it performs extremely well. Let's have a look at this cell now to see where she's sitting. Off. Let's do a voltage check. Voltage check across the terminals is 3.2 volts. It should stabilize at about 3, maybe 2.8 volts. Now, it's not yet fully charged, but as you can see, it does charge fairly fast. Now we're going to put a load on it. I'm going to short circuit it to see how many amps it pushes out. I have to up the scale. 20 milliamps going down. This is a short circuit. We shouldn't actually do this to a cell because it puts a lot of load on the cell, but it will maintain a load like an LED for quite a long period of time, for a couple of days in fact. I have compared it to a lithium ion. I put a lithium ion next to it and using the same little LED to burn, and this outperformed a lithium ion battery, which was at 100% charge. That was a 2000 milliamp hour battery, and this outperformed it and continued burning for an additional 24 hours after the lithium ion had already been completely discharged. The advantage being that it charges so fast as compared to lithium ion, which takes quite some time. Now this here is a similar thing. It's exactly the same, except that it has a bigger surface area. So when this thing pushes out, this cell over here only pushes out 20 milliamps. When it's charged for a longer period, say you let it charge for half an hour, it'll push out about 100 milliamps. But this one over here pushed out 2 amps. That's 2000 milliamps because it has bigger surface area of the collectors. This has got a very small surface area. But the advantage is that it also charges up very quickly, and one can use it as a flash charger for cell phones or for anything really. The properties have a whole lot of different applications. So for now we have a cell that is solid state. It's extremely light, it charges very fast, and it's quite powerful. It also gives off no gases. It's safe. You can puncture it, you can freeze it, you can put it in a fire. it doesn't get affected by any heat. Obviously the performance does change slightly when you freeze it, but when you heat it up, the performance actually improves. The material that's gone in here is very cheap compared to lithium ion, and it's non-toxic. So there are a lot of advantages to it. I plan to develop this cell further and start building an actual marketable product. I would like to build a flash charger for cell phones, and then also a building block that can be used in the building industry to build greenhouses or green homes or green buildings for energy storage, as well as any other application we can think of. So that's where we are right now with this cell. Thank you.